Okay, so you see my example 2 is blank just because I just went through example 3 and then realized I never hit record. But I do want to point something out. So keep this in mind as we go through example 3, that A is your initial value, so that goes in this spot. R is the percent increase or decrease written as a decimal. So some of us may have forgotten some things when it comes to decimals and percentages. All right, so if you want to go from a decimal to a percent, you either move, let me write in a different color. You either move your decimal 2 places to the right or multiply by 100. All right, just in case we forgot. If you want to go from percent to decimal, you do the opposite. So you move your decimal 2 places to the left or divide by 100. So if you're ever unsure, because these calculators do not have percent buttons, the fancy ones, because they expect you to know this. So just a couple of reminders as we go through the example 3. All right, so in 2015, the population of St. Johns County, Florida was about 226.4 thousand. So that sounds important. During the next 4 years, the population increased by about 4% each year. So increased is a keyword. 4% each year is going to be helpful. Write an exponential model. So that is telling us something to do. Write an exponential model. Remember, model means equation, not somebody walking down the runway. That represents the population Y in thousands, T years after 2005. Then we're going to estimate the population in 2019. So we're going to write a model and then we're going to estimate it. All right. Well, we know increased means what? We're going to use which model? The growth model, right? Because that one's increasing. What would this be? This would be our initial amount. And then the 4% each year is going to be our R value written as a decimal. So it would be 0.04 because we would move it 2 places to the left to go from percent to decimal. All right, so we have our information. Remember, your growth model from above is this. So we are just going to substitute in the information we now know. So our initial amount is 226.4. We got 1 plus our rate, which is 0.04 raised to the t power. So now we're just going to simplify this, just combine it. 1 plus 0.04 would just give you 1.04. So y equals 226.4 times 1.04 raised to the t power. So this is our model. All right, this is your exponential model. All right, so we got the first part done. Now we're going to estimate the population. So they said in the next 4 years, we could also take 2019, subtract 2015. That would also give us 4. So they gave us 4 in 2 different ways is what I'm saying. Sometimes they wouldn't. They would only give you one way. So we are going to find out when t equals 4, what would our estimated population be? So how are we going to figure that out? We're going to plug in 4 for t. So take our exponential model, and in t's spot, we're going to put a 4. And then we're going to plug that into our calculator and see what we get. All right, so we have 226.4 times 1.04 raised to the 4th power. And if y'all are wondering how I'm doing the exponent, it's just this button right here on the calculator will let you go to the exponent. And then we hit enter. So the population, does this make sense? We expect it to be more. Is this more than our original amount? It is. So I feel like we're on the right track. It is only 4%. 4% is not a lot. So, I mean, it is in this thousands, but as far as the number goes. So we would say that in 2019, let's round to tenths place like they did. So we're going to say 0.9. So we're going to say in 2019, St. Johns County, Florida, their population would be approximately 264.9 thousand people. All right, so again, if you have questions on these, you want to practice some more, please come see me. Okay, so we do have an example to practice for self-assessment. So I want you to pause the screen, give this a try. In example 3, assume that starting in 2019, the population of St. Johns County increases by 3.2% each year for the next 5 years. Use a model to estimate when the population will be 300,000. So this time, we're trying to figure out when do we think it would be 300,000. All right, so how many years? Well, they're telling us it stays this rate for 5 years, so let's go 5 or less. All right, and then how do we know what our initial value is? So if we go back to our question here, we're going this time by this initial value. So 264.9. So you're going to plug that into your model. So please give the model part a try. That means write an equation, kind of like we did here. And then I want you to estimate some years and see which one gets close to 300,000. All right, please pause now. All right, so hopefully you got this far. Hopefully you got to the exponential model. Now say you're like, okay, Ms. Gill, I got this part down, but I'm not sure how to do this. Start with year 1. So find out when t is 1, what is your y? When t is 2, what is your y? Until you reach this number. Okay, so give that a try. Plug in 1, 2, 3, 4, 5 for t and see what you get. All right, so t is 1, I've got this. 2, I got this. 3, I got this. 4, I got to the point that we were. If you wanted to go to 5, you would see that that was a little over 300. I think it's about 310,000. So in this case, we would say that the population will be about 300,000 in 4 years. So it would take about 4 years at that percentage rate for their population to increase to 300,000. So it would take about 4 years to reach the population of 300,000. Remember, when you're given a word problem, your answers should be written out in words. If you just left like this on a mastery check, I don't know what your answer is. So you have to put it in words. All right, we got one more type left to look at, and it is rewriting an exponential function. So we just wrote one, now we're going to rewrite one. That sounds like fun, right? Of course, Miss Gill, of course. All right, so I put this little picture here just so you could have a picture of what they're talking about in this, because we got some chemistry, science stuff going on. So the amount Y in grams of the radioactive isotope chromium-51 remaining after T days is Y equals A times 0.5 to the T over 28, where A is the initial amount in grams. What percent of the chromium-51 decays each day? So they're giving us the type of model which we know that it would be losing. So that would be a helpful thing to know. But what is it that they want us to find out? They want us to find out what is the percentage of decay. So that has to do with our R value, right? So our goal is to determine what percent decays each day. Okay, so let's start off with what we know. So they give us this equation right here. So let's start off with that. So we got Y equals A times 0.5 T to over 28. All right, so we need to get rid of this 28. And the way that we're going to do that is we are going to multiply. Okay, so I know it's been a little while since you've done power rules. But we are going to separate this t off of the 28. All right, so we're going to imagine this is like 1t over 28. We want to pull the t out like it's been in our other models. So what could we do to do that? So we could take our a value, leave it alone, and we are going to take the 0.5. All right, we're going to pull the t out. So what that does is that leaves 1 over 28 inside. And then we're going to pull the t outside. All right, why are we doing that? Because now we're going to work this out. We're going to put it in our calculator. All right, because we're trying to find what that percentage is. So in our calculator, we're going to put 0.5 and raise it to 1 over 28. And so what we get? So we get approximately 0.9755. So we're going to stop it at 10 thousandths place, so 4 places after the decimal. So we're going to say y equals a 0.9755. And now we got rid of that little fraction there and we just have a t. So now it looks more like our decay rate. All right, so how do we figure out what that percentage is? Well, we need to know what did you have to subtract from 1 to get this, right? So what did you have to subtract from 1 to get 0.9755? Well, we could figure that out by simply saying what's 1 minus 0.9755. So we have 1 minus 0.9755. That gives us 0.0245. All right, so then we're going to rewrite this as a to the 1 minus this number, because remember that's how we got this number. So it's kind of a little backwards, 0.0245. So we're kind of doing the opposite of what we were doing before. All right, so this would be our new model. All right, so what would this be as a percent? So 0.024, or 5, I left off the 5. As a percent, move the decimal 2 places to the right, so you would have 2.45%. So the decay rate is about 2.45%. All right, so I want you to try one and see if you're able to do it. So just follow these steps. It's very similar. You have one in your practice. It's very similar. So just follow the steps, pull the t out. You're just kind of going, they already combined everything. What was it originally? All right, so here is your self-assessment question. Again, you will not know if you understand this if you do not try. All right, so the amount Y in grams of a radioactive isotope iodine-123 remaining after T hours, and they give you that, where A is the initial amount in grams. What percent of the iodine-123 decays each hour? So you're going, it's very similar to what we just did, so please give it a try. Pause now. Try it in your notebook. All right, so notice I did it very similar to the last one. We broke it up, pulled the t out, worked this out. That's how I got this number. What was 0.5 raised to the 1/13th power. So that gave me this. Then I needed to figure out what was 1 minus that to give me my original model. So then I know that 0.0519 is the same as 5.19%. So the hourly decay rate is about 5.19%. So I know word problems can be challenging. If you have questions, we can look at some similar ones like this in class. So please make note of which ones you may have found challenging. Or if you think you'll be okay, but you get to the practice and it starts to get hard, we can always talk through your practice question and get the important information out. All right, so please see me for help, and I will see you in class.